mission, and in that same time frame, do the advanced technology development necessary so that you could actually do sample return, which remains a very high priority for the Mars community in 2018 and 2020. And I hope that's addressed your question.
Thank you, Dr. Squires. And I might, before I recognize the Ranking Member, Mr. Feeney, tell the audience and tell the rest of the committee that as when we end the hearing, and I think we'll have another round depending on people's time schedules, you're going to finish the hearing with some recent images from the Mars rovers. And,
I would enjoy doing that.
I know I'm very much looking forward to that. I want just everybody to know here that stay, because the end of this will end with a bang here today. So the Chair recognizes Mr. Feeney for 5 minutes.
So our technical budget questions are standing in between the audience and exciting video slides. Okay. Well, I'll try to make my questions penetrating then. The NPO ESS program has had significant problems over time, budgetary and meeting its goals. That led to the Nunn-McCurdy review. And ultimately that meant that a number of climate sensors were dropped from the satellite in order to limit cost growth. The program was also re-baselined at that point. Is NPO ESS meeting its revised schedule and its cost milestones? And what are the largest threats and challenges we have? Dr. Stern, why don't we start with you and then anybody else that wants to weigh in on that?
Yes, sir, very briefly. After the restructuring, the mission has been doing much better. It's a very ambitious undertaking, and simply put, we have a long way to go. It's still early days in the development of both the payload and the spacecraft. So while I think it's doing considerably better, we have to be ever vigilant.
Is anybody else, Dr. Moore? Yeah, please.
I think the program has had many problems, and one of the problems has been a technology hurdle associated with the imager, referred to as VIIRS. It appears that those problems are not yet behind us, and that perhaps for some of the geophysical variables like ocean color, we're not going to be able to achieve the requirement. I think the question that really stands before us is that each time we believe we have the instrument, shall we say, we're over the worst hurdles, a new hurdle appears. And so I think it's just the concern with the past performance that we've constantly stumbled, even though we thought we were near the end on this particular instrument. I agree with Alan that that I think that we are beginning to see, and not to use an old phrase, the light at the end of the tunnel, but and hopefully it's not the train coming towards us.
Well, and when we're talking about lights at the end of tunnels and we're looking into space, those are light years away sometimes. We don't know how long those tunnels are finite here on the planet. But Dr. Fisk, you raised the issue that's a concern to a lot of us on a lot of fronts in NASA, and that's the workforce issues. It's something I think all of us are focused on. It's not necessarily a specific budgetary issue, but you were the one that raised it in your talk. And I was interested, given again the parameters we have with the likely budget outcome, if you think that there are things we can do differently to excite future science and math scholars through our science program, or for that matter through the spaceflight program, if you think that there are different things that NASA can be doing, because it serves a twofold purpose in my view. Number one, we get kids focused on the subjects that they need to master for us to be a preeminent space society, and that's math and science, which also has a lot of import in other areas for our economy and strategic and military capabilities. But it also conceivably would help generate the sort of support that we're all looking for in the public for NASA's mission. So maybe we can get the $800 million to advance the Mars program, and maybe we can shorten the gap in the human flight. So it's a dual purpose if we can find a way to do it. NASA does, by the way, of all the agencies, they get more hits from school websites, they get more interest from teachers in the science field. So, Dr. Fisk, why don't you start, and if anybody else has any thought about what we can do within existing parameters to get that excitement started.
I think I've always thought of this problem in sort of two different ways. There is the question of encouraging people to go into science and math in general, engineering sciences as well. And there, just simply the excitement of space and making that available to the school system is obviously an extremely positive thing and encourages people to go into the fields. But it isn't the problem. There is a separate problem, which was once you've encouraged them to go into math and science in general, do they want to go into space? And that's a second problem because that problem comes up at the university level. You've encouraged people to go off and get training in engineering degrees, undergraduate degrees, and so on. And then they have a whole series of options available to them, which are in the best interest of the nation, whether they're, nanotechnology, various kinds of sensor technologies, any number of things. Then the question is, should they go and will the best and the brightest and go into the space business? That problem is actually not that difficult to solve, in my judgment, because what happens is, I think all our experiences, Jack Burns at the end, who, and all of us and Steve that are in universities have discovered that when you engage students as undergraduates in technical fields in participating in some aspect of space, research projects, hands-on experience, and so forth, they inevitably want to go into the space business. And they're encouraged to do so. They feel they see the excitement firsthand, and the converse is also true. When you don't, the lures of all the other disciplines. So the nation can decide if we need people in these fields. We have so many challenging activities coming up in space. We have challenging activities and our workforce is starting to get old in the space business, and as a result, we need to vet these people in. They need to be the best the nation can offer, and there's a very simple process that you can do that, engaging the universities, because by this point they've decided to go into the field. That happened earlier. Now the question is the yield factor for space. Thank you.
To turn the problems slightly differently, I think in your discussions that we had earlier about ITAR, this is an area where not only for the university community, but for the NASA centers, a fresh vision would be very helpful. I know that it's a burdensome aspect for JPL as well as for Goddard and other NASA centers. There are certain very real reasons for ITAR, but I think that they could be scaled back, and that would directly address what you've raised.